next key. So in this video we are going to discuss about T flip-flop. So how you are going to design the T flip-flop using Verilog, we have to see in this video. So before that we have to know the functional table of the T flip-flop. So the functional table of the T flip-flop is like this. So T, whereas the present state and whereas the next state. For two inputs we have the four combinations we have. So for t equal to 0, so what is the q value? It directly assigned to the next state. So for t equal to 1, so it will be toggle. If you give 0, it will go to be 1. If you give 1, it will be 0. So what is the present state? It will be toggle to the next state. If the t is equal to 0, it will be same as the present state. So it will be no change state. Sorry, it will be 1. It is no change state, whereas 0, it will be the toggle state. So by using these functional table, you are going to design the T flip-flop using Verilog. So this is the design code of the T flip-flop. So module, first you all know about that. You start with module keyword and then followed by module name and then followed by inputs comma outputs. So what are the inputs? Clock, reset and T. So our T flip-flop is look like this. So this is our T, whereas it is our clock. So present state and whereas the next state. So it is our T flip. So if you want to give, you can give reset also. So what will reset do means, if you give reset equal to 1, so means it will be come to the initial state, means your next state will, means your output is going to be 0. So it will be coming to the initial state. So what is the clock means? So for every positive of clock or negative of clock, what you present here, so for every clock edge of change, your input is going to be changed, means according to this always block. So if any change in the means, here we can take positive of clock. So what will happen? So for every positive of clock, so this block is going to be execute. Whatever the always block is going to be execute. For negative of clock, it is not going to be execute, because the whatever you write in the inside the sensitivity list, means what inside the parentheses, so that should be change, means if the what are the variables inside this sensitivity list, if there is any change in this particular parenthesis, that could be taken by the always block. If there is any change in particular thing, so it will be going to execute. If there is no change, it is not going to execute. So like that. So clock, reset, and another input is t. So it is a t flip-flop, that's why it is a t input, and output is the q. Means why you represent reg means, so always block, what are the variables? Here you can see q, you are assigning the values to q. So what are the variables we are using inside these always or initial blocks? That should be a reg data type. So if you don't mention reg, means it defaultly takes 5. But what is your necessary? It is a reg. So that's why I have to mention that is a reg data type. So next, always at the rate positive of clock begin. So what will happen means, for every positive of clock, this always block is going to be executed. If so, inside the always block, what will happen if reset means, if the reset value is equal to 1. So if the reset value is equal to 1, what will happen? Your here reset value are 1 or 0. If the reset value is equal to 1, what will happen? Your QL output of the T flip-flop is going to be 0. Otherwise means it is not the case. So if the reset is not equal to, means that means it is equal to 0. What will happen? So else if t means, if your t value is equal to 1, so see here, if the t value is equal to 1, what is your output? It will be toggle of the present state. So your next state is going to be toggle of the present state. Else other condition means t is equal to 0. For t is equal to 0, what will happen? What is the present state? It is going to be executed to the next state. So there is no change state. That's why you can simply give q equal to q, means q value is directly assigned to q. If the t value is equal to 1, then it is going to be toggle, means invert of present state. So whatever the always begin here, it will be end by using end keyword and module followed by end module. So this is the test bench code of our T flip-flop. So module followed by module name. So what are the inputs? That should be a reg data type. What are the wire? It will be a wire. Sorry, what are the outputs? That should be a wire data type. So why you make reg? Why not wire means? So what I already said in the design code, why I am explaining design code. So I already explained that what are the variables we are using inside the initial block or always block. That should be a reg data type. So that's why we make it as a reg. See here, clock, reset, t, these are the variables we are going to be using in this initial block. That's why we make it as a reg. So while q, so we have to connect this design code with test bench code. So whatever the design code we written here, it will be connected to the test bench code. How you are going to connect? By using these lines. So how you are going to connect means, first this is the syntax. So first you have to write the design code module name. So first you have to write the design code module name followed by DUT, instance name. So you have to write the instance name here. So you can write any name. DUT means design under test. It is a some formal way. So next followed by port connection. So how you are going to connect means here you can observe there is a T, clock, reset and Q. So we have to give the values to this particular flip-flop. So how you are going to give? We have to give from external, means you have to give by yourselves. In the design code you have declared some variables. You can't give values. So by using test bench, you are going to give the values to inputs and collect the output from output of the design code by using test bench. So see here you have to connect the test bench inputs. This is our test bench inputs. So reset, it is a Q. For your more clarity, T underscore TB and R I written is like this. So these are the variables of design code. So what are underscore TBs are the variables of the test bench. So what you are going to do means you have to connect this T underscore TB with T, means T with T. So you have to connect these two inputs. How you are going to connect? By order. Here I can connect with order. If you also want to know about name also, you can I already make a separate video on this port connections. You have to watch that. If there is any clarity misclarity, then you can comment on it. I make a small video about that. So until then, how you are going to connect? You have to connect clock with clock. So you have to know what is the order. Here is the order is clock, reset, T, Q. So same order you have to follow here. Clock, reset, T, Q. For your more, you can write like this also. Clock underscore TB, reset underscore TB, Q underscore TB, like that. So how you when you have to write means what are the variables? Here I represent clock, reg, clock, like that. If you mention like this means you have written the variables also here also same like this. So it may be clumsy. So forget about this. You have to simply follow the order. So what are the clock, reset, TQ? You have to simply write that order here same. That means your clock is going to be connected to the clock here. So again this reset is going to connect the second order in the reset here. So T is connected to T here. So like that Q will be connected to Q. So these are the test bench code variables. So whatever you written here is a test bench variable. So this will be going to connect in the design code. So by using this line you have to connect the design code with test bench code. So initial begin. So what you have done in the initial begin means you have to give different input combinations inside this initial begin. So first I give input values of clock, reset, T. After some delay I give again reset values equal means now the flip-flop is going to be execute according to your all else block. So you have to give different combinations like T values here, and after some delay we have to give finish keyword to stop the simulation, and then always block is going to be happen means for every 5 nanoseconds of time. Always means every time. For how much of time? For every 5 nanoseconds of time your clock is going to be toggle. So initially you give clock equal to 1. So for every 5 nanoseconds it is going to be toggle like this 1 0 1 0 sorry 1 0 1 0 like this is going to be toggle. So these last 4 lines are used to generate the waveform in EDA playground. If you are going to done this code in EDA playground you have to written these 4 lines. If you do this code in other Vivado tools or any other thing you can simply ignore these 4 lines. And last is end module. So this is our simulation output waveform. So how you are going to observe means see here. So first positive of clock, here you can see the reset value is equal to 0. So if the reset value, sorry, here don't consider this one. So this line is considered by this yellow line. So forget about these values. So you have to simply check here. So here see reset value is equal to 1. If your reset value equal to 1, what I said that your Q is automatically equal to 0. So your Q value is going to be 0 here. So next pause of clock here. So for every pause of clock it is going to be executed. That's why I have to simply check pause of clock. See here your reset value is equal to 0 means whatever the, if you can observe now T value. So T equal to 0. So T equal to 0 means what will happen? Your Q will be toggled of the Q. So see here Q value is equal to 0. It will be toggle 0 toggle means 1. So you have to get 1 here. So for next positive of clock, see here your reset value equal to 0. Okay, fine. Then you have to go to the T value. T value is equal to 0. T value is equal to 0 means Q equal to 0 means what is the present state? It will go extends to the next state itself. So see here Q value is equal to 1 here. So this will be passed to the next state also. Q is equal to 1 here also. So next go to another positive of clock. Here the reset equal to 0. Next we have to go to the T is equal to 1. So for T is equal to 1, what will happen? What is the present state? It will be going to be toggle. So here it is 1. So it will be toggle to 0. Here the Q value is equal to 0. So like that you can cross check whether your design code or functional table is matching with your waveform or not, whether you are giving correct values to your test bench code or not. So cross check your both design code and test bench code according to your waveform and functional table. If you got any errors, try to rectify it. Then also you don't get any particular solution for that particular errors you didn't understand, means you simply comment on it. I make some small video and small clarification among that. So don't hesitate to ask anything, and thanks for watching. Thanks for keep supporting me, and until then, bye.